Next up is the topic of simple circuits, wherein we look at the concepts of current, voltage, resistance, Ohm's law, resistors in series and parallel connection, as well as Kirchhoff's rules. First, we have Ohm's law. Put in simple terms, you have an electric current or simply current when there are moving electric charges. Variable for electric current is capital I, and the unit for current is ampere. Now, charges move when there is potential difference between 2 points. The charges will move from one point to another if there is potential difference between these 2 points. Potential difference is also referred to as voltage. If you consider, for example, a voltage source, a battery, an AA battery, for example, a battery has positive terminal and negative terminal. The positive terminal refers to high potential, and the negative terminal basically refers to a low electric potential. Between the two terminals of the battery, therefore, you have high potential and low potential. You have potential difference. You have voltage. The variable for voltage is capital V, and the unit is volts. The relationship between voltage and current is given by Ohm's law. V is equal to IR. V is voltage, I is current, and R is resistance. The variable for electric resistance, capital R, and the unit is ohms. Resistance is basically property of the object. That is to say, when an electric current passes through an object, it will encounter resistance R. Resistance R will depend not only on the material that the object is made out of, it also depends on the size and shape of the object. Any object or electric circuit element whose sole purpose is to provide resistance is referred to as a resistor. Any voltage source is called the power source or power supply, or a source of electromotive force, EMF source. There are two types of EMF sources. We have ideal EMF source and real EMF source. For an ideal EMF source, the terminal voltage is equal to the EMF of the source. For example, if you have an AA battery, you have the positive terminal and the negative terminal. If you are to put the probes of a voltmeter on the terminals of the battery, the reading of the voltmeter will be terminal voltage. EMF is the rating of the battery. If you look at the side of the battery, for example, AA battery, written on the side is 1.5 volts. That's the ideal voltage that the battery can provide. That's the EMF of the battery. For an ideal EMF source, terminal voltage is equal to the EMF rating of the source. On the other hand, for a real EMF source, the terminal voltage is no longer equal to the EMF of the source. That's because a real EMF source is made out of an actual material, is made up of an object. Therefore, the EMF source itself has an internal resistance small r. When the current passes through the EMF source, therefore, Ohm's law tells us there's a corresponding voltage, IR. Therefore, terminal voltage is equal to the EMF of the source plus minus IR. Plus minus, it will depend upon the direction of the electric current. When the current enters the positive side of the EMF source, you use plus sign, whereas if the current enters the negative side of the EMF source, you use negative sign. So if the current enters the positive terminal of the battery, V is equal to EMF plus IR. But if the current enters the negative terminal of the EMF source, terminal voltage V is equal to EMF minus IR. And that's it for now. In the next video, we'll cover resistors in series and resistors in parallel connection.